Alright, welcome back. So today we're going to be doing the first part, which is the idling around or patrolling, or whichever one comes first. So we're going to have our dude just chilling here. What we're going to do is first we're going to make the pathing. So we're just going to make the guy just go around onto these 4 points. So we just got 4 points sitting over here just chilling. And then we got a path maker, which basically just has all these 4 points as children, just to keep it neat and tidy. Put it like that. I made a script inside our path maker. Don't have anything at the moment, but basically we got all these stuff in here. And then we got a float weight and an int num, a spline graph pointer to a path. A spline graph is basically a way to make spline, so basically making a path. So we're just gonna make a little path, make the object go walk around, and that's gonna be his idle state. And then once we're done with that, we're gonna do the other states, and then we're gonna integrate it into our machine. So first, let's actually make the path making. So the path making has the path, weights, and num, and then we have init update, and we have a render path just so we can see it. And yeah, so let's start this up. The first thing we're going to do is we're going to initiate the path, and when we're inside our Unigine, we have the object to move, which is the enemy, and then the duration time is the time it takes to move from one point to another point, and then the points, I just made 4 points right now. Yeah, it's going to be procedural if you guys know how to do that. Basically make it into a for loop. So in the moment, we're just going to do the path equals to Unigine spline graph and then create. So that creates a path, and then we're just going to add these points. So for each object, so let's just do a simple for int I equals to 0. I is less than the path size. So I think it's better if I just move this right here. Let's close the shooter AI for now. We'll deal with that later. And then we're going to do the path points dot size. Right, and I think this is going to make it an error, and this is making an error. Okay, so now that's done. And then for each points, we're just going to add it. So we're going to do a path add point, and then we're going to add the point, which is basically going to be the path points I, all right, and then get world position. All right, this int is coming back for some reason. Okay, so now we created the points that we have. And let's just put one more circle. There we go. So now we have, in our case right now, is 4 points. So the maximum length of these points. So the next thing we're going to do is actually add segments. So segments and points inside our path are basically, the points would be the 2 dots, and the segment would be the line connecting the dots. Now, there's one more thing, and it's called a tangent, so where the line bends. So we're going to be coding that too. And we're just going to make it a little simple, so it's not going to be too hard. So the way we're going to do it is just going to be a path add segment. Okay, and now it's going to ask for a few things. So it's going to ask for the start index, the tangent, the start up, the end index, the tangent, and the end up. So this takes care of our point, our tangent, and the up vector, or which way it looks up, so it can calculate rotation for our thing. So we're going to use all of them, and we're just going to do a simple segment numbers. So our first thing is our segments are from 0 to max, and since this is 4, it's going to be 0 to 3. So we're going to do 0 as our first index, and then we're going to choose the starting tangent. Now the starting tangent would be which way we want it. Now the fastest way to do it is, if you have a point, the starting tangent would be forward, and if you have an end point, the end tangent would be backwards. So if that's the easiest way to actually think of it. So if you have let's just go here. If we have a point and we want the forward and backwards of a point, it's going to be the y-axis, which will be the forward, and that's the forward tangent, and then the x-axis being the negative y-axis being our end tangent, or the back tangent. So that's what we're going to do, and this is just for simplicity. You can actually add your own style and your own movements, but for now we're just going to use that front and back. So we're going to do path points, and then we're going to choose the number itself, so the index that we're in. Okay, and then we're going to ask for get world direction, and we're going to do axis, god damn it, 3 of those. We're going to do axis y. Okay, so now we got the forward direction, and then we're going to do the direction that we want for its up. So that's going to be its z-axis. So we can just copy and paste this, and instead of y, we're going to change it to z in capital. Okay, so that's done with that. Let's just put a comma and press enter. So now we're here, and now we're going to do the end. So the end index would be the next line that we're going to connect, which is going to be 1. Let's just put it all together, 1. And then we're going to choose the next line that we're going to hit it. So we're going to just copy and paste this all the way here, and then we're just going to paste it. And the difference, what we're going to do is we're going to change this number to 1, and we're going to change this number to 1. So now we have this. Now there's one more thing we're going to change, and that is our end tangent. So we can't be facing the same way. We're going to be facing reverse. So that's going to be the back of the thing. And the up vector is always up vector. That doesn't change. And now we have a segment, a line between 0 and 1, facing forward and looking up. So now we can just copy and paste this 4 times and just change the numbers. Wait, just press it, enter, 3, 4. Okay, so now we have this. So now we can do, so now that we have, okay, let's just, alright, so as we changed it, we also realized that we have to make it into a circle or a loop. So we're going to go back into our 0. So 3 connects it to 0. So 0 to 1, 1 to 2, 2 to 3, 3 to 0. So that connects us, and then just change this, 1 second, 2 to 3, 3 to 0. Okay, so that connects our segments and our path. So now we have everything connected. And with that, let's actually start moving this or rendering it. We can render it first so we can see the path. And let me just let's just put it in here first. Render path. So now we can render it, and then we'll just choose like I don't know, segments, and let's just make it constant so we don't have to change anything. Constant int segments equals to 50. So we're gonna have like 50 lines, or like 50 dots and lines per thing, so we can make a line, make it smooth, and we can have a proper lining. So then let's just make a for loop. We got an int, and then the length would be path get number of points. So how many points we have? So for 4 we're going to, let's visualize those points, right? So let's just call them, which is going to be point, which is going to be path, oops, get point, and then choose the point. So now we have the point, and then a visualizer. Oops, I'm using Unigine. Alright, we use a visualizer to render a 3D point, and we're going to use that path. So point. The float size, we'll just use 0.01f, good enough. And then the color would be math vector 4 underscore black. Good enough. It's gonna be a black might be too bad, so let's just use red. It'll be more bright. Okay, so that gives us that. Now we're gonna do another for loop. This one's going to be an int, and the length would be segments. All right, actually it's going to be the number of segments in the path. So path get num segments. All right, and for each segment we're going to have now this is extra. I'm just gonna speed this one up, but basically we're just going to render our extra segments, and then inside it we're going to render our for loop. Alright, so now that we have our thing, I decided to just put it in all in one line, because technically speaking there's only like the same amount of points in segment. There's like 4 points and 4 segments, right? Because we're going in a circle, we're gonna have the equal amount of points and what's it called, segments. So we don't really need to make 2 for loops. We can just put it all in one. And then the last thing we're gonna do is actually use that segments int. So we're just gonna do a for loop, and then int, right, I is less than the length being segments. All right. Oh yeah, actually we need to add this inside our other for loop. So let's just do that. So I'm gonna do for int I, make this j, and then the length would be segments. All right, and now we're doing that because what we're gonna do is we're gonna do another vector 3, and we're just gonna have 2 points. Okay, so we're gonna have p0 and p1, and p0 equals, no, minus, equals to path calculate segment point. All right, it's gonna be calculate segment point, and then we're gonna just do this, and then we're gonna choose a point between the segments. So we're gonna do point between I, comma, so index and a time frame or an amount. So we're gonna do j divided by segments. So what this means is 0 out of 50 point, so it goes in a percentage, right? 0 out of 50, 1 out of 50, 2 out of 50 gives us a percentage, and it's going to give us a dotted line between these points. Okay, so that gives us that, and then we're gonna do the same thing except for this guy. Let's just copy and paste this. We're gonna copy the same thing, except for this guy we're gonna do a j plus 1, because we want 51, or we want the next point. Okay, so once we have that, then we can do yeah, god damn it, I can't even spell anytime. All right, visualizer, and then render line 3D, and then it's gonna ask for 2 points. We're gonna give it p0, p1, and then color, I'm just gonna choose white this time. All right, and then now we have a white line, and we can just end it, and we can actually see this, and I think we should just see it, just so we can. All right, so now that we're here, we got our little line, we got the end points, so the line just goes, comes back, and then we got two arrows, one is the front and one is the back. We can change the color of that later, but now we have a path, and it made a path, and now we can put the guy and he can move across this path. So let's do that. First things first, let's change the color. Okay, so now we're gonna update this. So how are we gonna update this? There's a few ways to do this. I'm just gonna choose the very super simple, easy way that I've been doing for a while, and we're gonna use the weighted method, which is our weight right here. Okay, so what we're gonna do is we're just gonna do weight equals to, and yes, you've guessed it, it's going to be a clamp in brackets, and then we're gonna do the Unigine mat game get IFPS. All right, and we're gonna divide this by the duration time that we have right here. So we're gonna divide this by the duration time, and now why we're doing this is if it's 5 seconds and get FPS gets us to 1 in 1 second, 1 divided by 5, 1 over 5, it's going to take us 5 seconds to go through this line. So now we're going to press comma, is going to ask us for the smallest number. We're just going to do 0.0f, and the largest clamp is 1.0f. So that gives us our number to that. Alright, so what we're going to do now is we're just going to say if weight equals to 1.0f, so if it reaches its max, we'll reset the weight, so weight equals to 0, and then we're just going to increase num plus plus. So we have a number here that's just equal to 0 at the moment, and then we're going to increase it by 1. Okay, and then the last thing we're going to do is we're going to percentage equal it, so we're going to modulus it, and we're going to modulus it to the path get num points. Alright, so what this does is we get the maximum amount of points that we have. Alright, and if the number goes up, it's going to modulus return it, so it's going to go in a circle. So 0, 1, 2, 3, and then instead of 4, it's going to give us back 0, so it goes back over here. And now the path is there. We can keep on going up forever, but this just makes it a little bit cleaner, I guess you could say. Alright, next we're going to do a vector 3 point, and we're just going to call it path calculate segment point. All right, so we're going to use the number, so which index of the points, so between 0 to 1, 1 to 2, 2 to 3, 3 to 0, and then the float we're going to choose is the weight, because the weight goes from 0 to 1. Now the reason why it only goes from 0 to 1 is taking the percentage between the segments. So we got our point there. Next we're going to, other than point, we have something called direction. I'm just going to call it dir, and that's going to be our direction, and then the last thing we're going to have is the up vector. So we got that, and then we could just do a path calculate segment tangent, because it's the direction. All right, and we're just going to choose the same thing, num weight. All right, and then for up vector, we calculate up vector, same thing, num and weight. Okay, so now we have these positions. Okay, what we're going to do is we're going to get the object to move, set world position. All right, so we're just going to do a normal position movement, so we're going to set it to the point. All right, then object to move, set rotation. All right, or we can do set direction. Rotation would be boring, so world direction. All right, and now it's going to ask for a direction vector and an up vector, and then the bottom vector, which is reset, which is automatically down, we don't touch that. So we're actually, it's gonna ask us, that's gonna be the forward direction. We're gonna change that too. So first is the direction, which is the dir, then the up vector is the up, and then let's change this to Unigine math axes y. Okay, axes y. So now we have the thing correct, blah. So let's just press play and check it out. So now we have the object moving inside our thing. It's gonna take 5 seconds to get there. Once it's there, it's gonna move right, and we got our little point that's black, red and green, there, that, and now we have our object patrolling in a position. So now that we have our positions and our thing, we can calculate everything, and we can even add more. So we can do the whole thing. Now we got our object that's just chilling here, and we're in the middle, and it looks like he hasn't seen us. So yeah, as you can see, he's following the lines to the point. He's following the lines to the point. There's a little bit of difference because of, well, math, but you get the idea. He's doing it. Okay, so we got that going with the path making. Next thing we're going to do is we're going to integrate it into our AI so that he moves as he's idle. Moment he's alert, he does something else, and then all the other stuff, something else. So until next time, we have our object making a path. And you guys remember, I have it all on GitHub, so you guys can always check it out. And yeah, that's about it. I'll see you guys next time. Goodbye.